Dear students, so far in vapor power cycles, we have studied about the ideal Carnot vapor power cycle, followed by that Rankine cycle, and the reheat cycle, and the regenerative cycle, and also we have studied about the factors affecting the efficiency of the Rankine cycle. So now we shall discuss. We have already discussed about this ideal regenerative cycle, actual regenerative Rankine cycle. Now in today's class we shall discuss about open and closed feed water heaters. What do you mean by this closed water or open or closed feed water heaters? These are nothing but the water that comes out of the pump after the condenser must be heated up before entry into the boiler. So that is by way of regeneration. So the input water into the boiler must be heated by some means. And that means is very much clear from this turbine. In regenerative cycles in the earlier class, we have seen that. So here from 4 to 4 dash, is the here the water that comes out after this pump enters into the turbine casing and gets heated up, and then it is sent to the boiler. So that is how making use of the heat that is available in the turbine. So it is used for heating. So unlike that, in these systems, we can see that the turbine, the various points 1 to 2, there is an expansion of, this is always a superheated steam at condition 1. So that condition 1 steam enters into the turbine. There is a partial expansion taking place from 1 to 2. And let us consider 1 kg of steam entering into the turbine. Now, 1 to 2 is the expansion of 1 kg of steam. When there is an expansion, if this pressure is P1, so it is expanded to pressure, lower pressure, let's say P3, and intermediate pressure from 1 to 2. So during which a partial amount of this steam mass m out of 1 kg is taken away from the turbine, Right from 2 to 3, what mass remains is 1 minus m, and that expands from 2 to 3. So 1 to 2, 1 kg of steam expands, and from 2 to 3, 1 minus m kg of steam expands. At 3, we can see that it is the saturated steam. This point 3 is the saturated steam that enters into the condenser as usual. The amount of heat rejected in the condenser is Q2, and that is from 3 to 4. This saturated steam is converted into saturated liquid at 4, that is sent through this pump, and in the pump, pressure is imparted from 4 to 5. There is a pressure imparted from 4 to 5, and that enters into this chamber. This is called as open feed water heater. That means the water that comes out from this enters into this open feed water heater. Now the partial expansion of this mass m is taken from this turbine. It is here at this point 2, this mass m of steam taken from the turbine, which is in the superheated condition, that is also made to enter into this feed water heater. This is a mixing chamber, so wherein both gets mixed. There is open mixing taking place. The condition at 5 is a water, the condition 2 is a superheated steam. Both gets mixed over here, and the resulting point, what we can see is at 6 that comes out. 6 at this point is 6 that comes out. Now from 6, it again enters into a pump, and it is pumped to a pressure, this P, point 0.7, and from 7 to 1, at condition 7, it enters into the boiler. Now this is the point, this is a subcooled liquid state. From point 7, it enters into the boiler and gets heated up to superheated steam. So amount of heat addition in the boiler is only from 7 to 1. Otherwise, if this is from 3 to 4, 4 to 5, the amount of heat added would have been from 5 to 1. But this is avoided by this feed water heating, and now the state reach is 7. At 7, uh, the water enters into the boiler, gets heated up, and it is converted into superheated steam. This is open feed water heater. That means two streams get mixed here. One is the mass of steam in the superheated condition at 2 enters here, and second one is after this condensation point is 4, and when it is pumped it is at point 5. It enters, this water enters, steam enters, both gets mixed, and at point 6 there is an exit. This is a saturated liquid state again at pressure P3, and then from 6 to 7 it is pumped to this point. So point 7 is the pressure, or it is the subcooled liquid state which enters into the boiler and heat addition takes place. So this is all about the ideal regenerative Rankine cycle with open feed water heater. Open in the sense both these streams get mixed. Condition at 2 and 5, superheated steam and liquid water gets mixed, and it comes out as 6. Now if I can write the expressions for the various quantities, like what is the amount of heat addition in the boiler Q1, what is the amount of heat rejected Q2, and what is the work of expansion in the turbine and work of the pump work WP. I can write an expression in terms of the enthalpies. Let us understand how to have written these values. Q1 is the amount of heat added in the boiler. So water at condition 7 enters and comes out at condition 1. So difference in enthalpies would be H1 minus H7 is the amount of heat added. Is the amount of heat added. So what is the amount of water that goes here? It's 1 kg. So here when M mass is added over here, what comes out of the turbine is 1 minus M. 1 minus M, and that expands from 2 to 3. That expands from 2 to 3. 1 minus M. So this is all 1 minus M that enters over here. M enters over here. Finally at 6 what we get is 1 kg. 1 kg of the working substance. So here it is 7. So that is why H1 minus H7 it should be multiplied with 1. Q2 is the amount of heat rejected. Q2 is the amount of heat rejected in the condenser. In the condenser, and here here this must be multiplied with 1 minus M here. This must be multiplied with 1 minus M here. 1 minus M, because the amount of steam that enters into the condenser is only 1 minus M. It is not 1 kg. So 1 minus M into H3 minus H4 is the amount of heat rejected. Then the work of expansion WT, there is an expansion from 1 to 2 and 2 to 3. For both these, we'll have to write the expression. From 1 to 2, 1 kg of steam expands. So 1 into H1 minus H2 plus. So from 2 to 3, only 1 minus M kg expands, because M kg of mass of steam is already taken away. So what remains is 1 minus, what remains is 1 what remains is 1 minus M, 1 minus M into H2 minus H3 for this. So the total expansion would be 1 to 2, it is 1 kg of steam, H1 minus H2 plus 1 minus M into H2 minus H3. And how we have written for WP? There are two pumps, WP1 and WP2. And WP1 and WP2. And for this, WP1, what are the conditions? 4 and 5. 4 and 5 are the conditions, Then we can write for WP1 as, and what is the amount of steam? It is only 1 minus M for pump 1. So 1 minus M into H5 H4 is for the pump work for 1. Pump work for second is, so when both gets mixed over here, this is 1 minus M, this is plus M. So what comes out at 6 is 1. So 1 into this, the change in enthalpy H7 minus H6, H7 minus H6. So thus it is written, and you can, as usual, write an expression for the efficiency as WT minus WP divided by Q1. So this is all about the open feed water heater. The name is given because hence both these streams get mixed up. Both these streams gets mixed up. So that is why it is called as open feed water heater. Now let us understand the closed feed water heater, the ideal regenerative Rankine cycle with closed feed water heater. Now you can see the difference only regarding this. So both these streams at 2 and 5 do not get mixed up over here. They are made to pass through separate tubes and there is an exchange of heat taking place from this steam and this water. They do not get mixed over here. Instead, a mixing chamber is used over here. A mixing chamber is used over here. They get mixed up, and it is very much clear from this diagram. So as usual, from 1 to 2, 1 kg of steam expansion. From 2 to 3, it's only 1 minus m as usual, because m kg is already taken over here and it enters. And at condenser 3, at this point, after expansion, so 1 to 2 to 3. At 3, it enters into the condenser. It is completely condensed into liquid at 4. And from 4 to 5, it is pumped, and this condition 5, and it enters. There is exchange of heat between this steam coming out of the turbine and this water coming out of the pump. The exchange, this water gets heated up at point 8. So this water from 5, it gets heated at point 8 on the diagram as shown. And how about this steam? From 2 to it goes out as 6. So from 2 to from 5 to 6. So this is a point. This is a point. Again, it is pumped with W2 from 6 to 7. So 7 is the condition after the condition of this steam after passing through this closed feed water heater in the pump. This is the condition 7 for the steam. This 5 goes out at 8. This is 8 and 7. So 8 and 7, they get mixed up in the chamber, and the resulting point is at 9. At this point, it comes out as a liquid that enters into the boiler. Now at this point 9, the amount of heat addition takes place in the boiler till a saturated, till a superheated condition is reached. What is the amount of heat added in the boiler? Right from this point 9, right from this point 9 up to 1. So, so that is how it operates. This is a closed feed water heater in the sense the two streams do not get mixed here. That's the only difference. Open, they get mixed, but here they pass through separate tubes. There is only exchange of heat taking place. So there also, because of the proper mixing, there is a more amount of heat transfer taking place. But here it is less amount of heat, what heat transfer that takes place. There is a difference. So let us understand very quickly these points. 1 to 2, 1 kg of steam expands. 2 to 3, there is again expansion of 1 minus m kg of steam. It is expanded up to 0.3. 3, it enters into the condenser, comes out as the saturated liquid after the condenser. It is pumped to pressure 5. It enters into this feed water heater. Now, at condition 2, the steam, a partial steam mass of mass m kg enters into this feed water. So what is the condition? It is 2. And as a result of which you can see that there is a loss of heat and it attains this point. It goes over here. Both, after 2, it attains a point 6 over here. It attains a point. This has become saturated liquid. Now the 5 that enters as a liquid over here comes out at 0.8. Comes out at 0.8. So there is a heat addition taking place from this steam. So earlier temperature was here at 5. Now the temperature has been increased up to 0.8. So this 0.8 and this 0.7 after when at 0.6 when it's pumped, its pressure is increased as well as its temperature increase is 7. So 7 from the pump and 8 from this the exit from this pump P1, both gets mixed up at 7 over here and 8, and the resulting point is 9 in the mixing chamber. After the mixing chamber, it is at this point 9. So at point 9, so it's here at point 9, it enters into the boiler and heat addition takes place and it is converted into superheated steam. Now the amount of heat added gets reduced. Instead of at 5, the amount of heat added start from 9, because you can see that the temperature at 5 is less, but the temperature at 9 is more. That means this is by feed water heating. There is an increase in the enthalpy. There is an increase in the enthalpy, and that is why the amount of heat added in the boiler gets reduced, increasing the efficiency. So this is about the closed feed water heater. Open feed water heater and closed feed water heater. Now let us understand the difference between the open feed water heater and closed feed water heater. Open feed water heater, it's very simple, simply because both you just require a chamber where both gets mixed up. But this is complex because of the tubing arrangement. Because of the tubing arrangement, or because they do not get mixed up over here, you require some sort of tubing arrangement. It acts like a heat exchanger. So that is why it is a bit complicated, complex. And because of this reason, you can see that it is more expensive, but here this is less expensive. Now heat transfer is effective as two streams mix over here. Heat transfer is more effective because both gets mixed, but here they do not get mixed and heat transfer is not that effective. But here for open feed water heater, a separate pump is required, but it may not be required. It may not be required in case of closed feed water. Here you may not require a pump over here, but however it is required here. So these are the main differences between open and closed feed water heaters.